So this tutorial is on how you can choose your scale appropriately when graphing. So the first thing that you have to do when you're making a graph, like a bar graph or a line graph or some kind of graph that involves a scale, is to think about your highest number that you need to get to. So what you want to do is look at your set of data and look at what is your highest number. So let's say, for argument's sake, your highest number was, I don't know, 125. Okay? So that means we need to go up to 125 on our scale. To do that, we want to count first how many squares we have. So let's say vertically we need to get up to 125. We're going to count how many squares we have. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19. We've got 20 squares. So then what you have to do is you have to think about what a reasonable scale might be to use all the space of your graph possible. Because, for example, if you just went 20, 40, 60, 80, 120, you might only get as high as that. You want to try to use all of the space that you have. So what you typically do is take the highest piece of data, so let's say your highest number is 125, and you divide it by how many squares you have. So as an example, 125 divided by 20. So that answer is 6.25. So in theory then, you could do it perfectly with each square being 6.25. But mathematically that doesn't make the most sense. Making it 6 also isn't quite going to work out so well. So you want to choose a number that will work out better. Sometimes you want to think about choosing a number that's like multiples of, for example, 5 or 10. So some people like to go by 2s or go by 5s or go by 10s because those numbers are easier to work with. Certainly for this one, you could go by 10s. Go 10, 20, 30, 40, 50, 60, 70, 80, 90, 1, 10, 20, 30. And you'd get up to about there on your graph, which is pretty good. Or you could go by, say, 8s. Why am I choosing 8s? Because 8 is a little bit of an easier number or a more even number to work with than 7 might be, and 6 isn't big enough, and 5 isn't big enough. So I would say for this graph, if your highest number was 125 and you had 20 squares, using anywhere from a scale of 8 to 10 or even 7 would be reasonable. Then what you do is you start labeling. So you could, if I was doing 8s for example, I label each of the lines, and I can do that. Or what you could find is this could get a little tedious. So sometimes what people will do is they'll label every other one. So for example, I'll label that one 40, and I'll label that one 56. And so you can skip and then label. So that would be 64. We skip to 72. We can skip to 88. That one would be 96. So we can go right to 104. And then you could keep going by skipping, and by the time you're done, you're going to end up past or around where 125 would be. And so you know you've chosen a scale that's going to work. One really important thing is that you start right from the bottom and that every box represents the same distance. So for example, if this is 8, this is 8, and this is 8, and this is 8, and so on. Likewise, your x can be a completely different scale. For example, let's say you surveyed, I don't know, let's say along the bottom the biggest number for your x was 15. So that was your biggest number for your y, which is the vertical axis. This is your biggest number for your x, which is your horizontal axis. What you could do if you were 15, again, count the squares, but you're going to find out that you've got more than 15 squares. So using a scale of 1, 2, 3, 4, etc., all the way, and again, if you want to skip, you can, but you go all the way to 15, you're going to find that that works quite nicely. It's okay that the x, or the horizontal, has a different square from the y, or the vertical, as long as you're consistent within each. So down here, each square represents 1. Up here, each square represents 8. So that's just an example of how to choose an appropriate scale for a graph.